Hello everyone. Today we will talk about divisive clustering. So divisive clustering is another way of hierarchical clustering. In agglomerative clustering we have seen that we start with every object as an individual cluster and then we go on joining some of these objects at say later stages and then we finally end up getting one cluster. Correct? Whereas in divisive clustering the approach is exactly opposite. We start with all the objects in one single cluster and then we go on dividing them into further smaller clusters till we finally end up getting every object as one cluster. Hence, this is also known as top-down approach, whereas agglomerative would be known as bottom-up approach. So, we have seen in detail the method for agglomerative clustering and we did carry out some exercises manually also. So how do we carry out divisive clustering? Now divisive clustering is slightly more complex. Okay, why? Because in agglomerative at every stage we have to join only one group or like only a pair of objects, so it's easy to locate it via distance matrix. Whereas in the divisive, at every step we have to carry out some sort of division of one object into two groups, okay, two subgroups. So what we need is a subroutine with some flat clustering algorithm. What do I mean by that? Let me try to explain in detail. So initially we have all n observations in one cluster. Okay, we have all n observations in one cluster. Now at the first step I need to create two clusters from this. So what do I do? So I use the flat clustering algorithm. Use flat clustering algorithm to create two subgroups or two clusters from this one. Okay, so basically to create two clusters means to split the cluster into two parts. Now what do I mean by flat clustering? I could go for two means algorithm. We have studied k-means, right? So I could go for two means. So I take that one cluster and use two means to get two clusters. Correct? This is one approach. Another approach is we can try something like Ward's linkage but in the opposite direction. So let's consider all possible subgroups. So given n observations, there are many ways in which we can put these n objects into two groups. Okay, and then try to see for which combination the change in the error sum of squares is the highest. Okay, so when you have everything in one group, your error sum of square is going to be, let's say, SSE naught sum of squares, and when you split you are going to have say SSE1 and SSE2. So SSE naught is going to be of course higher than SSE1 and SSE2. So we have to choose that particular split which would increase the distance between this. Means if I compute say average SSE here, okay, so average of these two, then we choose that algorithm which creates maximum gap between this. Okay, is it okay? Average or total, doesn't matter. The gap between this and this should be highest. So you consider all possibilities. You have one object here and n-1 others here, and then all possibilities with 2 n-2 and so on. Is it okay? So this could be either something like two means or something like Ward's linkage in opposite direction. Okay. So this is how you split one cluster into two. But of course we don't have to stop at 2. We have to go on till we get every observation in its own cluster. So what we do at the next step? Now that I have two clusters, I choose one of these clusters to split. And which one should I split? The one which has higher error sum of squares. Okay. So choose one of the one of the new clusters as a candidate for the next split. Choose one of the next clusters as a candidate for the next split. And how do I choose? We choose the one which has highest error sum of squares. Okay. This is done by locating the cluster with the highest error sum of squares among the current clusters. Error sum of squares means within cluster sum of squares. Okay. Highest within cluster sum of squares among the current cluster. So we basically find out which cluster is most heterogeneous. Okay. Of course, if we are talking about categorical data, then we'll have to define within cluster sum of squares differently. We may not have to talk about squares. We may talk about absolute differences for ordinal categorical data, etc. So basically, a more accurate way to say this would be locate the cluster which is most heterogeneous. Okay. Among all the clusters, locate the cluster which is most heterogeneous. So it is up to us to decide what sort of measure for heterogeneity we have to use. Okay. So locate the cluster which is most heterogeneous and consider it as a candidate for the next split. And take it as a candidate for the next split, and then this cluster is split into two via again the same flat clustering algorithm which you use in step 2. Okay. So repeat steps 2 and 3 till we get all the observations in their own clusters, all the observations as separate clusters. That is, till we get n clusters. Okay. So we have this candidate cluster. You split it again either via two means or via Ward's linkage. Then again among the new clusters, you locate the cluster with the highest heterogeneity and you go on repeating this process. Is it okay? Is it clear how the divisive algorithm is supposed to work? So carrying it out manually is slightly difficult because you'll need so many two means at every step. But if you get the idea, then you can write a code. Okay. Now, because it involves another clustering, manually it is difficult, but at the same time, it could probably be more efficient in terms of algorithm, computational intensity. Why? Because if you use two means, then you don't need big distance matrices. The problem in computing, the problem with respect to computing as far as hierarchical agglomerative clustering is concerned is that at every step you need to deal with big distance matrices and you need to find out the smallest entry in them, etc. Okay, because at the first step you have n cross n, then you have n minus 1 cross n minus 1, n minus 2 cross n minus 2, and so on. Whereas here, if we are using say 2 means, then at every step you have to just compute only n cross 2 distance matrix. Okay, as a result, computationally, divisive algorithm is much more efficient than hierarchical algorithm. Than agglomerative algorithm. Okay, both are hierarchical. And another advantage of divisive algorithm is it is said to produce more reliable and stable clusters. Why? Because you start with all the objects in one cluster. So you have information about all the objects together and then you find out what is the most suitable cluster. Whereas in hierarchical agglomerative, sometimes it tends to first rely only on local information, so only on the relationships between a certain subset of observations, whereas here, because we are having everything together at the beginning, it is kind of like making use of global data. Okay, hence it is said that people have established that many a times divisive algorithms produce better results than agglomerative algorithms. Is it okay? So now that you have some idea, I think at least for small data set, you can try to manually carry out the divisive clustering. Okay, so let me stop here. Thank you.